Hello everyone, today we will introduce the project of sequence game of Group 46. Our team members are Tianjing, Fu Wei, and Li Hua. We used three techniques for these projects: Q-learning search, game theory model, and heuristic search. For each technique, we will talk about three contents: design decisions, challenges, and improvement. We will also show a game demo in the end. This board game could constitute an iteration on DP model, set board states as states, playing cards as actions, and the feedback from different cards on the different board positions as rewards. Considering all possible situations of card actions, the Q values of all possible next actions in the current state are explored in each iteration to construct a Q table with huge computational complexity. We also might some problems during the development. Since the states and the actions are high-dimensional, it's difficult to maintain a huge Q table with several episodes in 1 second. Besides, it's not easy to build a good evaluation function because of difficulties in deciding the rewards of the situations. To solve the time-consuming problem, we try to limit the exploration of actions, as well as applying one episode iteration. We also considered using the deep Q network algorithm by combining the CAN and Q-learning, which could transform the Q table update into a function-thinking problem. Both of the methods will save much time.
Game theory is the process of modeling the strategic interactions between multiple rational players. In sequence game, to maximize the payoff and win the game, agents have two strategies: either to focus on forming series of chips for their team, or prevent the other team from forming series, which will call defense and offense respectively. As we can see in the game theory tree, choosing defensive strategy is rational for our agent to maximize benefits. Therefore, in the actual implementation, our goal is to find the space from available actions where more straight lines can be formed. For the challenges, since in the actual game, agents are not able to know the real-time actions of the opponents, therefore, the intention of the strategy used cannot be very accurate. In addition, due to the time limit, the payoff does not count the series of both teams on the game board, which can be improved by minimax algorithm with hour-based pruning.
Now let's move on to the final part, heuristic search. The first thing we thought was how to make a heuristic function. The first method was to count how many chips of the same color were around the chip that was placed in the last action. Such positions are easier to form a sequence, but such a heuristic function is obviously neither goal-aware nor reducible. Therefore, we considered goal-counting heuristic, one of the most commonly used methods. For example, whenever there are 4 agent chips on the board, we assume that they are only one step away from reaching the goal. In terms of search algorithm, we directly try to use the most common A-star algorithm. However, we know that similar algorithms such as greedy best and weighted A-star may have better performance, so the best way to decide which one to choose is to do experiments. We eventually found that adjusting heuristic weights would get better results. The first problem we encountered was that we needed new cards to expand the nodes. We built a simulator to solve this problem randomly. A bigger problem is that the basic search algorithms are too slow. We experimentally found that searches over 5 layers were almost meaningless, so we limited the iteration to almost 5 layers. And at the same time, we used the evaluation method as the new heuristic, which only does a local check.
Now let's do a demo. In this game, the blue side is our final agent and the red side is the agent that just used the evaluation function. We can see that the red side occupies the middle position first, which is very unfavorable to us. With that in mind, let's see what happens later.
That's a clever move. Did you notice the 5 hearts in agent number 3? Removing the opponent's 5 hearts not only gets us out of danger, but also allows us to occupy the middle position in the next step. See, it beautifully completed a sequence, even though the opponent has completed a sequence. You'll see we've got the game in our hands. Well done, we've destroyed the opponent's middle area and completed 2 sequences quickly.
This table shows the winning rate of our 3 agents compared with other techniques. We can see that the weighted A-star heuristic model outperforms the others. That's all. Thanks for listening.